This is the Data General one of the world's truly first laptop computers, really deserving that attribution. And while it was in many ways ahead of its time, it was so flawed that it literally bombed. But what has this all to do with this IBM PC convertible? And was the DG1 really that bad as everybody says? Let's go and find out. Retrocomputing is the use of older computer hardware and software in modern times. I'm the Vintage Collector, and these are my stories. Released in 1984, the Data General 1 was a truly astonishing device. It brought along two 720 kilobytes 3.5-inch floppy drives, a full-size 80 by 25 CGA display, up to 512 kilobytes of RAM, and also ran on batteries. When powering up the DG1 for the first time, I get greeted by a series of long beeps and an error 11 display on screen. Both are indicative of lost CMOS configuration data. Most computers can be instructed to continue the boot process anyway, and this machine is no exception. I received one boot floppy with this machine that I do hope it still works. And so it does, eventually greeting me with a very specific boot message of being a Data General Corporation Revision 2.0 release of MS-DOS 3.2. Now that's interesting. Of course, I was preparing myself a prompt a little bit, especially gazing around at winworldpc.com if there was a specific OEM version of DOS for the Data General 1. And obviously there was. However, the portal only lists an OEM release 4.0, but seeing the release 2.0 missing on winworldpc.com tells me that I should preserve this disk at all cost. As mentioned before, the DG1 features dual 720 kilobyte floppy drives. We all know that the 3.5-inch floppy drives eventually took the reign over the 5.25-inch drives. However, when the DG1 came out in 1984, the inclusion of the 3.5-inch drive was technologically too advanced and became more of a hindering point. And we're going to better understand that in a minute or so. But first, I have to deal with the question why the second floppy drive doesn't seem to work. This is easily recognized when trying to access the second floppy drive. If DOS asks you to insert the diskette into floppy drive B, even if one was previously inserted, then the drive is not known by the BIOS. DOS then tries to switch over requests from drive B to drive A, transparently passing them through the primary floppy drive. Now, manual PCs have no built-in configuration utility. It will not be an exclusive phenomenon of the 80s, but was still seen throughout the 90s as well. Especially IBM and Compaq, but also some other manufacturers did provide the BIOS configuration utility on specific configuration and diagnostic floppy disk sets. As I didn't observe any pre-boot, press delete, F1 or whatever key to enter BIOS messages, I did research how to configure the BIOS on the DG1. I was really surprised to learn that the DG1 in fact didn't require any configuration diskette, but indeed already had built-in configuration and diagnostic utilities. But how to call them up if there is no prompt in the first place? Well, it turns out to be super simplistic. The menu screen you see here is always shown whenever there is no floppy disk inserted. So from this menu, pressing F3 will enter the BIOS configuration. In my case, using the F2 key to switch between 1, 2 and 3 floppy drive configurations. I will set it to a 2 floppy drive configuration. And look at this. Upon retrying a dir command on drive B, I would finally get to see the directory listing from the second floppy disk. Maybe you eagerly want to tell me in the comments that I should fix my camera or add a better focus setting. Don't. I know about it. What you're witnessing here is indeed the very bad screen quality of the DG1. Most historic reports revolve around the very bad viewing angle. Unless you're sitting straight in front of the display, you can barely read it. A pity, as the 80 by 25 columns display on a portable machine of this form factor was unheard of at the time. And this brings me back to the second major flaw of this machine, which unfortunately was the inclusion of the 3.5-inch 720KB floppy drives. Well, wait, the 3.5-inch drives were too advanced, you said? Right, because back then, in 1984, the DG1 was the very first machine to sport the 3.5-inch floppy drives, while the vast majority still used the 5.25-inch machinery. So you can imagine that it was almost impossible to get software on a 3.5-inch medium at the time. Users had basically only two choices. Either buy a 3.5-inch floppy drive for your desktop machine or buy the external 5.25-inch floppy drive option for the DG1. And this is where the buyer's option for selecting 1, 2 and 3 floppy drive configurations come into play. The third option was to enable exactly said 5.25-inch floppy drive as an additional data exchange option, because in the end, you needed either of the two possibilities to transfer your software and data from and to the DG1. I do have a lot of equipment around, so it would not be a problem for me creating those 3.5-inch floppies, would it? Well, it turns out that my Compaq Armada that I frequently use to bootstrap other machines pretends to write 720KB floppy disks. So I used it as usual to transfer over the disk images, for instance the aforementioned Data General Revision 4.0 release of MS-DOS 3.2. Though I would end up having a bad surprise as soon as I tried reading the disks on the DG1. No matter what I tried, I'd always end up receiving critical read errors. But wait, you can use laplink. Hack in the mode and CTTY commands and have your host machine copy over the transmission program via serial host-to-host connection. Well, nope. No matter what I tried, it wouldn't work. Of course, I knew already before trying it that it would probably not work. Obviously, Data General didn't use the Intel 8250 as the UART IA controller, but a different CMOS version which was not register compatible to the IBM standards of the time. Of course, faithful as I am, I had hoped that more recent versions of Laplink, such as Laplink XL or Laplink 5, would have fixed that in later releases, but obviously not. I had also given it a try using FileMaven, 530, Fastlinks and even Kermit. And the latter two were literally the best I could get, but see yourself. So in Kermit, when connecting to the other machine, I would at least end up seeing garbage like this on either direction. So at least something was transmitted, though obviously totally distorted and not even barely usable. Sort of the same would happen in Fastlinks. It would yell at me about port failures, which I believe is because of said incompatibility of the UART chip. However, it as well would show me some garbage received on the line connection when running both ends in diagnostics mode. But in the end, no matter which settings I tried, I will not get it working. And this should get you some idea already how exactly this must have felt like back in 1984. So I'm reverting back to floppies, as the serial stuff seems to be a dead end. And while I'm aware that my Compaq Armada obviously can't create the double density 720KB media, I'm calling this 1986 IBM PC convertible for help. This machine has double density disk drives as well, and also a known good serial and parallel port connector. I use Microsoft Interlink that came with MS-DOS 6. As opposed to other tools like Laplink or FileMaven, Interlink works more like a file server through a serial or power port connection. So instead of synchronizing directories between the two hosts, you get a network drive with a drive letter on the client machine. This way you can access all files on the remote host as if it were on a local drive. This makes it far easier to deal with bigger amounts of data. And as expected and hoped for, all disks created in the IBM PC convertible were perfectly readable on the DG1. This essentially was also the trick which allowed me to create all those floppies with the different serial transfer programs as mentioned in the previous chapter. The DG1 also offered a built-in serial terminal client. If all that serial transfer was not working, maybe I could give it a try using a serial terminal then. So I hooked it up to my Altair 8800 and PDB-11 replica machines to see what happens. As mentioned before, you end up directly in this menu screen if no floppy disk is inserted. Pressing F2 gets into terminal mode, it's as easy as that. Though again, no matter what I tried here, it wouldn't work. Though maybe the terminal emulation of said replica computers is not exactly what the DG1 expects. I read a bit about it and noticed it was intended for other data general systems, so not necessarily third-party platforms. Once I found more time, I tried to chase down how this could be simulated to at least see it in action one day. But hey, with all these failures so far, I should see at least one success, right? Remember the long beeps in the beginning and my assumption about the dead CMOS battery. So I would start the disassembly by removing the large battery block. I did a quick measurement with the multimeter. No surprise, this battery is dead. On the backside there's many screws to unfasten, and while it didn't harm, it was totally unnecessary. Most of them hold the keyboard or the mainboard in place. Actually, only the 3 center screws, 2 larger and a smaller one, must be removed for the case to be cracked open. On the left hand and right hand sides there's these small trim panels which must be removed. Beneath those panels you find these black clips, which you have to remove as well. Just pay attention, you're not gonna lose them. Once all clips are removed, the top cover can be gently lifted away. Just pay attention to the display power cable on the left hand side of the case. You must also disconnect the ribbon cable of the LCD display. This one is accessible through the backside of the battery compartment as shown here. Once all cables are disconnected, you can simply slide the top cover away. You will immediately spot the CR2025 cell for the CMOS RAM. Simply swap it out using a matching replacement cell. And while this has nothing to do with the CMOS battery replacement, let's throw a quick look at this drawer here. The mainboard came with a stock 128 KB of RAM, where each of these modules added an additional 120 KB. This machine was fully loaded with 3 extra RAM modules, bringing it up to a whopping 512 KB. And here we also have a close-up of the ATC88 CPU, which was a drop-in replacement for the Intel 8088. As opposed to the original in the IBM PC, which clocked at 4.77 MHz, this one is clocking in at 4.0 MHz. Reassembling the DG1 is straightforward. Start with the top cover and slide it back onto the base unit, then reconnect all wiring. Especially the display ribbon cable is fumbly to reattach. Then you secure the case from the underside using the screws. You may notice that there is already some screws in place here. Remember what I said before about not all screws needing to be removed. So I put them back previously and now only the additional 3 screws must be secured. Then you reuse the retainer clips to reconnect the top cover to the base unit, and finally you reattach the side cover bezels. And this concludes my look into the Data General 1. Replacing the CMOS battery was an undertaking on its own. Yes, it can be done, but I firmly believe this was never intended to be a user-serviceable activity back in the days. What else? Well, I've shown you the bad viewing angles of the display. As I said in the beginning, the DG1 was technologically ahead of its time, but that was also one of its major issues. How helpful is it to have a full-size 80 by 25 columns display if you can barely read it? But that's not the only thing. You've seen my struggles to just get the operating system diskettes created. Well, you can't blame the Compaq Armada for failing to write the 720 kilobyte floppies in the first place. But you probably got an idea how it must have been back in the days when you had neither another machine with a 3.5 inch drive nor the external 5.25 inch drive for the DG1 available. With that being the major issue number 2 back in 1984, this leads us directly to the third problem. Why, for God's sake, did these people at Data General not implement the Intel 8250 for the serial I/O? I mean, I tried really everything, from contemporary software to more recent versions, but literally all of them failed big time. The DG1 was so short-lived that there was really no point in making this software work, so it seems at least. But since it has a built-in terminal emulator, I wanted to give it a shot on the Altair 8800 and PyDP11 replicas, but again, to no avail. I would probably need to emulate some very specific serial console to get it to work. And so it remains to say, it is a very interesting piece of history and technology. Though, in my opinion, even with most bleeding edge technology for the time, it failed for good reasons. I hope you liked this video, and if you did, then please give me a thumbs up. Thanks for watching, and see you next time. You're about to see some potential upcoming topics for future videos right now. Please let me know in the comments which topics you are particularly interested in. Of course, you can also drop me in some other topics you'd like me to chase down.